Alright, so check this out. We have a polynomial and we want to graph it, and we also want to figure out when is f of x bigger than 0. We want to see when it's positive. Alright, first thing, I want to graph this thing. Graphing this thing is pretty straightforward. I'm going to ask, what kind of function is this? Is it a parabola? Is it a cubic function? Is it to the fourth power? What is it? It's cubic, right? Of course it's cubic because it's got three things to it. X, x, and x. I mean, if I were to multiply this out, if I were to multiply just this part out right here, first, outer, inner, last, I would get an x squared term, right? Then I need to multiply in this term over here, and I would have an x cubed term. So you're absolutely right, it is a cubic function. What's nice about writing it like this, now this is in a special form called factored form. What's nice about having it in factored form is it tells you exactly where the zeros are of that function. What I mean by that is, when is f of x equal to 0? Well, it's when this thing right here is equal to 0, or when this thing is equal to 0, or when this thing is equal to 0. This is equal to 0 when x equals -1. So I know x equals -1 is one of my x-intercepts. This is equal to 0 when x is equal to +2, and this is equal to 0 when x equals +3. Note that if x equals +3, this is not 0 because 3 plus 1 is 4. 3 minus 1 or 2 is 1. It doesn't matter what those are, because if this third term is 0, then you're going to have 4 times 1 times 0. Everything dies to 0. Similarly, if you have x equals 2, this is not going to equal to 0. X, or 2 plus 1 is 3. But when you multiply it by 0, everything gets killed. That's why I can kind of take these things individually and say, well, either this is 0, or this is 0, or this is 0, because if this first thing is 0, it doesn't matter what everything else is, the whole thing dies. Graphing this, is it a standard happy, I guess there's no such thing as a happy cubic function, but I mean, if it's a positive cubic function, it will start low and high. If it's a negative cubic function, it will start high and low. What do you think it is? Is it positive or negative? All right, I think it's going to be, you have no clue. Okay, fine, that's fair, that's fair. It's a positive cubic function. The way you can kind of tell is, if I were to multiply this whole thing out, I would get something like ax cubed plus bx squared plus cx plus d. I don't know, just a bunch of numbers here, 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 and here. And I would get x cubed, x squared, x, and no variable attached to it. What I'm asking really is this a positive number? Is it, and positive 1 is totally a valid number to deal with. And the answer is, it's positive 1. Because you multiply this x times that x times that x, you'll get 1 times 1 times 1. Or you'll get x times x times x, which is x cubed, with a 1 in front of it. If there were a negative in front of one of these, then that's something different. If there were a negative in front of one of these, then you would have negative x times x, which would be negative x squared, times another x, which would be negative x cubed. So that would be a negative cubic function. So what you want to do is you kind of want to just take a look at the sign of the things in front of the x terms over here. If I tapped out a big negative sign out in front over here, then obviously this thing would be a negative function. Does that make sense to you? Now, I'll be honest with you, I didn't multiply this whole thing out to make it x cubed plus x squared plus x plus some constant, because they didn't ask me to find the y-intercept of this thing. They just asked me to kind of roughly graph this thing. If I wanted to find the y-intercept, that would actually be pretty easy as well. I would kind of take the same hint as multiplying all these front terms. What I would do instead is I would multiply all the back terms. So what is 1 times -2 times -3? That would be 1 times -2 is -2. Multiply that by -3, you get +6. So I know that this thing crosses way up here at +6. Let's see. Let's go like this. 1, 2, 3, 4, 5, 6. So at x equals positive, or y equals positive 6, the thing crosses. I would say the graph looks like this. Probably something like that. Now, if you want to plug this into Desmos calculator or graphing calculator or whatever, feel free, and I bet you it would look something vaguely resembling this. This might go up a little bit higher, this might go up a little bit lower, maybe not as up or not as low as this, but it will kind of have that same properties. Really what I'm asking here is, when is f of x positive? Now f of x is positive. It's almost laughable how easy it is once you have the graph. Because you take a look at this and you say, okay, well, f of x is positive when it's in between -1 and 2, and when it's in between 3 and infinity. Can you see that? Can you see that right off the bat? When is this thing positive? Well, when it's in between here and here, and when it's in between here and above. Yes, you can see that? No, you can't? Come on, help me out here. Alright, cool. What I kind of want to do, a little bit separate to this, is I kind of want to do it without the graph. What I kind of want to do, and I'm not 100% sure where I'm going with this, but I just think that it's a very important skill to have. So I'm going to do it without graphing the thing. Because I think that this is probably going to come, I know that this technique is going to come up later on, and so I'm going to teach it to you now. I'm going to introduce you to this concept now. But let's take a look at this. What I would do, and I think I even remember, I taught 6th grade at one point in my life, and I even remember teaching 6th graders how to do this. It's not a hard technique. Where did I use this? I feel like I would use this when I hit calculus, to be honest with you. But here's the technique. It's not that hard at all. You make a number line, okay, without the graph. We're asking, what is this without the graph? You make a number line, and you pick out some important points. 0 is always on my number lines for some reason. 2 is on this number line, 3 is, and -1. And then we'll go, you know, whatever. All right. You guys remember number lines from 4th grade, right? All right. So what the point that I'm trying to make is, these are important numbers because those are my zeros, right, of this function. And then what I'm going to do is I'm going to choose some number that's in. It kind of shows me 4 regions. It shows me this region over here, this region over here, this region over here. So we'll call this, I don't know, we don't need to call it any names, but if you want, I can call this region 1, region 2, region 3, and region 4. Cool? This is just, this area over here is separated by this -1, and then this area over here, and then this area, and this area. All right. What I'm going to do is I'm going to choose a number that's in that region, that's in a particular region. And I'm going to see whether or not f of x in general is positive or negative. So, let's choose a number that is in region 1. Tell me a number, any number, that is in region 1. -2, perfect. That's a perfect number. All right. And I don't really even care about actually calculating out what f of x is. All I really care about is it positive or negative? Now I can remember, this is definitely used in calculus 2. So I'm trying to teach you the technique now. Is it positive or negative? Now, if I plug in -2 into this term right here, is that going to be a positive or negative term? All right, it's going to be a negative term because -2 plus 1 is -1. All right, so I've got a negative number. If I plug in -2 into here, is it a positive or negative term? I was just going to say, wait a second, it's 0, but then no, that's not right. If I plug in +2, then it would be 0. But if I plug in -2 into here, that would be another negative number. And if I plug in -2 into here, that would also be another negative number. So if I'm multiplying a negative times a negative times a negative, that would give me a, well, negative times negative, that gives me a positive. but then you multiply that by another negative and you get a negative. So in this region right here, it's a negative number. Let's choose another number in region number 2. And I'll be honest with you, my favorite number to choose is probably 0. I love plugging in zeros just because, I mean, it's so simple. If you plug in a 0 here, that would be a positive, a negative, and a negative. If you multiply a positive times 2 negatives, you get a positive number. We're good. All right, now let's choose region 4. I'm going to save region 3, not for any particular reason, just because it's hard for me to think of a number that is in between 2 and 3. Let's do it. Let's not be wimps. All right, let's talk about region 3. We're going to choose a number between 2 and 3. Let's try 2.5. If I have 2.5 over here, this would be positive. 2.5 over here, and that would still be positive because 2.5 minus 2 is just a half. So you still got a positive number. And then we put in 2.5 over here, and that would be a negative number because it's 2.5 is smaller than negative 3, so it would be a negative number. If I multiply a positive times a negative, I get a negative number. Region 4, let's try that. Let's choose the number 10. I know I could have just chosen 4, but I want to choose something definitely in that region, 10. So if I put in 10 over here, that would be positive. That will also be positive. That would be positive. So I'll have another positive number. So really, without even graphing it, in which regions is this thing positive? Well, between -1 and 2, and between 3 and above. Cool?